They're the same.
Yes. So X would be 124 degrees.
Okay.
All right, so now there's the other type of problem going the other direction, which is in some ways easier. So first thing here is to find the arc. If this is 136 degrees, what's the measure of the arc here?
136.
Right. And then this one actually may require a third circle here where you say, okay, I want X and this is 136 degrees. How do I find X?
Divide 136 by 2.
Yes, so it'd be X equals 68 degrees. All right, so these are just the starter kind of warm-up questions here. One other thing to talk about before I give you some more difficult problems, if you go all the way around a circle, how many degrees is that?
360.
360 degrees, good. And if you have a diameter like this, what's the arc? What's the arc measure of each one?
180.
Yes, okay. Now, occasionally, let me draw one more. This is another scenario you'll see. Occasionally, you'll see something like this, where there's a diameter, and then there's a 90-degree angle here. That's a kind of a justification for this being 180, because the 90-degree doubled gets you to the 180.
Right, okay.
Okay, so that all of this may appear in next few problems that we look at. Okay.
Okay.
All right, so just a couple for you to try. Please ask questions or work it out if you feel confident with it. But I'm just looking for the final answer here.
Is it 55?
And you're giving me the final answer, right, for X?
Yes.
Okay, so if it's 55, which I think is right, this would be 110, and 150 plus 110 is 100. So yes, that is correct.
Okay.
All right, now here's another problem for you to look at. I know these are kind of basic, but they lead to the more complicated ones, so we'll get to that.
Okay. Is that one also just 27?
It is, and so there's some congruences that you'll see. Okay, now it like your textbook misses doing sort of these step up problems, but we can now do a problem from your textbook that's a little more complicated for this. So there is enough information to find each of these. This little m here, that's what we've been doing in all these other problems. Like when I said, hey, what's the measure of this arc right here? And I'm just labeling it. The correct notation is this little m, 2 letters or 3 letters for the arc, and then this little curved line here. That's like the proper notation. All right.
Okay.
So I want you to, I think you can do this visually. I don't think you need to write much down here for this, but I'd like you to give me any of these arcs that you know. Obviously they don't ask for AB, but you can certainly give me that if you want to start out.
AB 50.
AB would be 50, good. And if you had the drawing in front of you, you could label it as you go. And I'll try and do that here for you. But go to the next one. They are in a reasonable order here to do.
BC 90.
Okay, good.
For ACD, that's
When you're given 3 letters, it's a major arc. And that means that a couple of things. One is that it's more than 180. But you're going in that direction, like you're going from A to C and then to D. You have to go in that order.
oh, I thought it was A to D to C.
You're doing letter C, is that right?
Yes.
Yeah, so you follow, you have to go in the sequence that it tells you. So you're thinking maybe of angles or something. A C to D is what's, and I guess I'll change the color here. It's the red one here.
Okay, well then 230.
Yes. Okay, why don't you try for BAD?
Um 180.
Yes. And that's from B to A to D like that.
Mhm. Then for ADC 220.
A to D to C. So we got, you said 220, 90, and then this one right here, 130. Yeah, it's 220. Very good. All right. Any questions on that?
Nope.
Okay. So there's another type of angle that I couldn't really tell if your book covered it, but it's related to these. So the next type of angle is, here's the center of the circle, and you draw 2 chords now. Okay, so 2 chords. So notice they don't go through the center, and they're going to give you, I'm going to call this, let me use little m and big M and X. Okay, so X is the angle right here. It's also the same as this angle right here. So X is little m plus big M divided by 2. Did you see any problems like that?
I did not know.
You did not. Okay. All right. It's coming. When will you see it? Oh, you know what? So we're doing some stuff in 10.5 now that I'm looking ahead a little bit. But you said you've seen the kind of the inscribed and the central angles or not?
Yes, I have.
Yeah. Okay. Well, let's do some of these. We got plenty of time here. So here's a couple of worksheet problems for you to think about. it's literally the average. Like it's not any more complicated than that. You take the average of the two arcs. Okay.
Okay.
All right. So here again, to find x, you have this one arc 129, this other arc 71, and you find the average of those two. So could you do that for us, please?
Yes. Um, 100.
Yes. All right. Got it. All right. Now let's have you do one more for put in a more difficult type of problem here. So sometimes they don't give you one of, so notice they gave you two arcs to find the, I don't know, it's called the interior angle. This X is the interior angle. They can also give you one arc and one interior angle. So this one's, you need a little bit more setup to do this. You have to recognize that 40 is the result of taking 52, adding it to X and dividing by 2.
Okay.
So I know I've done that verbally, but maybe you could try working that out. And I'll work it out if you're still having issues.
Okay. Is it 28?
It is 28, yes. So the setup here is 40 equals 52 plus X divided by 2. And yes, X is 28 degrees. Okay. Now, one thing you should notice here is that every problem I've given you, the X is, it's not really the central, it is called the interior angle, but it's lined up with one of the arcs. Do you see that? Like
Yes.
it's lined up with that. So let's say, like, for example, in this problem, I wanted Y. How would we find Y given that this is 40?
You do 180 minus 40.
Yes. And similarly here, if we wanted Y, it would be 180 minus the value. You said X was 100. So Y would be 180 minus 100. So occasionally they give you problems where they ask you for the Y and you have to find the X first. Or in this problem here, I'm about to snip in, you have to find the interior angle. So you have to find the interior angle. You have to find this time like Y or Y, they're the same. And then to get X, you have to subtract it from 180.
Right.
Okay, so if you could solve this for Y and then X for me, I'd appreciate that. Then we can look at some other problems having to do with chords.
So Y 63,
Okay, and that's just the average of those two. I agree.
and then X 117.
Yes, yes. Okay. So there's three types of angles inside a circle. There's the central angle. This is our summary, central. There's the inscribed. See how it's on the circle, and the central's on the center. And then there's just the interior angle, which is off center, we'll say. Those are the three ones that you'll see in this course.
Okay.
Among other things, but okay, let me quickly look at your book again. Okay, these are sort of interesting problems. We'll look at these. They're numerical, so we'll see if these are helpful. Okay, find the measure of an arc that is 3/5 of its circle. So here's a circle. What do you take 3/5 of its circle to mean, especially when referring to an arc?
Is it like 360 divided by 5?
It's 3/5, really close, of 360.
Okay.
So could you do that calculation for us, please?
Yes. 36.
That doesn't seem right. Sorry, I'm just I didn't grab a calculator. Maybe it is. No, 3/5. You're taking 360 and multiplying it by 3/5.
Um, 216.
Yes. Okay, now what about this last one here? 70% of its circle. What does that mean to you? 70%.
70% of 360.
Yes. So like literally 0.7 or 7 out of 10 of 360. Will you do that calculation for us, please?
Yes. 252.
Okay. Very good. All right. So now let's move to talking a little bit about chords in a triangle. So do you remember the difference between a chord, a diameter, and a radius? Could you give me some information on those, or just describe the differences, or tell me what each one is?
Okay. The radius is from the center to a point, to a point on
Yes.
the swing. And diameter is from one point to another going through the center.
Okay, so it starts on the circle, it ends on the circle. It's made up of two radiuses. Okay, good.
And a chord is like just from one point to another, but it doesn't go through the center.
Good. Okay, so let's try one problem here where I first ask you to identify a couple of things, then we'll do the numerical calculations here. So let's say this is A, B, C, D, and E. Give me a chord, a radius, and a diameter.
A chord BD,
BD, good,
a radius ED,
good,
and a diameter AD.
good. And these should all have little segments above them, right? Okay. All right, so now let me redraw this. Copy it, not really drawing. So we want to find X, okay? But before we find X, I want you to find A. I want you to first find A for me, please. How might you do that in this problem? Like what do you see here?
You have to find the short leg first.
Yes, but what I'm asking is what, like, without, I'm trying not to tell you the answer, but I'm trying to get you to tell me what shape do you see here?
Oh, triangle.
Triangle. So how do you find the third side in a triangle? If you're
Um,
given two of the other sides.
y- you divide the long leg.
What you're giving me is for 30, 60, 90 triangle. We don't know that this is 30, 60, 90. I'm just asking more generally.
Oh, the Pythagorean theorem.
Yes. So I'm
So
not asking you to do that, but I wanted to remind you that it is 7, that this does hold true, that it's a squared plus 6 squared equals 7.1 squared. Okay.
okay.
All right. Now, so we can find a. We don't need a, but we could find a. Can you tell me what the value of y is and why? And this is not drawn to scale, but
It's 7.1
yes, but why?
because it's a radius and all radii are equal.
Exactly. Now here's the big one that you've been wondering about, or this is what this problem is testing. The value of x is 6. Okay. And here's why. Here's why. Let's say I added another side length right here. Okay. So we've got two triangles. We've got triangle A, B, C, and triangle ADC. We can prove that these are congruent. And there's many ways we can do that, but here's one of them. Radii are congruent. Would you agree with that?
Yes.
This is congruent because the reflexive property. If
Yeah.
this angle is 90 degrees, what must this other angle be?
90 degrees.
So we've got angle side side. Is that enough?
Yes.
This is the one that teachers don't like.
Oh, no.
No, we're not allowed to use that. So that's not enough here. What else can we do? Well, look at the big triangle. What kind of triangle is the big triangle? Two sides are congruent.
Isosceles.
Yes, which means the base angles are congruent. And you might think, well, that doesn't help. Well, it does because you can actually use hypotenuse leg because the no choice theorem, because the angles are also the same up here. Because if these angles are the same, then the other angles have to be the same because this is 90. So there's a bunch of ways to do it. You end up using either side angle side or hypotenuse leg or something like that. But you basically prove the triangles are congruent. And that's why this length here, 6, is equal to this length here. So more generally, here's what's happening. You're going to get a problem where there is a radius. You're going to have a chord that meets that radius at a 90-degree angle. These are congruent.
Okay.
Did you see that in class?
Yes.
Okay. So we're going to work on some problems now that illustrate this point. That's the key takeaway, though.
Okay.
All right, so here we go. I'm going to label some different letters here and ask you to find A. 4.3 is this right here. C, D, and E. Okay, and then we'll find X at the end. What is the value of A?
10.6.
Okay. We don't have to calculate C, but what is the process for calculating C?
The 10.6 squared plus 4.3 squared.
And what is that called? What is that overarching relationship?
The Pythagorean theorem.
Yes, yes. So it ends up being whatever it is. It doesn't actually work out nice. What is D and what is E in this problem? and X for that matter. Try not to overthink it. You don't even have to calculate this. I'm just asking for what is DE and X.
Like, can I say like C squared?
It's C. It's C. It's just C. Like whatever C is, so are D, E, and X.
Okay.
Why is that? What's another name for C, D, E, and X?
Radii?
Yes. And you just said it, all radii are
Congruent, right?
congruent. Yeah. Any questions on that before we do another?
No.
Okay. All right. So here's a good problem. You do have a calculator available to you today?
Yes.
Okay. I'm just gonna have you try one here. This may be way too difficult, or you might say you got it right away. I do want you to calculate X. If you need a hint, please let me know, but I'd like you to try it out before I give you any sort of hint on this one.
Okay. 15.7 is the half of the
It's this one right here, right there.
okay.
And please use a calculator and round to one decimal place as needed.
Okay. I think I need help on this one.
Okay. Here's your hint. I'll give you two hints. Draw this right here. And that's also 18.9. And then find B. That will also help.
Okay. Oh, Um, okay. Is X 10.5?
Okay, you're probably very close, or that is the right answer there. I didn't actually calculate it. Let me get caught up to you here. Did you find the value of B, or can you tell me the value of B?
The value would be 10.5.
Okay, so 18.9 squared minus 15.7 squared. Yes, 10.5. Now B is 10.5. What is the whole B plus X? What's this whole thing?
21.
It's a radius.
Oh, okay.
Right? So it's the whole thing is 18.9. And so if you subtract,
Oh, 8.4.
yes.
Okay, got it. Okay.
All right, so quite a bit to do there, but it's not I mean, it's not an impossible problem. It's just it's kind of the same thing here. So let me have you try one more of these. It's basically the same setup. Um, put that in front of you.
Okay, I got 9.4.
Yeah, perfect. Awesome. So the kind of the same setup here is you draw this other triangle, you realize that that's 15, or you could even draw this other one over here. Doesn't really matter. And then you find that missing side. I call it A. A is the square root of 16.7 squared minus 15 squared. And then you get that number, and then you subtract it from 16.7 minus a, and that is 9.4.
Got it.
All right, so there's a lot more here to chord and arcs. I mean, you're just kind of getting into the start of it here. So some final thoughts here is that you'll see some problems where you've got a diameter, you could have a triangle like this, and you could also even have something where it maybe breaks it up in half, stuff like that. So you've got all kinds of these types of drawings that could come at you. So just be aware. I mean, we've only kind of scratched the surface of this for tonight. It looks like you guys are going into also for angles and outside the circle. So I didn't really cover this. We just talked about stuff inside the circle, but there's 3 cases for outside. There are what are called 2 secant lines. And secant means it touches in 2 places on the circle. 1 and 2, 1 and 2.
Mm-hmm.
There are 2 tangent lines. Oops, that's a terrible drawing. That's a terrible one. There it is. There it is, slightly better. 2 tangents. So tangents touch in 1 place. And then there's the mixture of the 2. There are tangent, secant. And here's the thing that you may or may not like about these is you when you're looking at these problems in the class, they're going to give you problems where you have to find something to do with the lengths, and then sometimes the angles, sometimes the lengths, and sometimes the angles. So that's coming maybe tomorrow or the next day in your class there with secants and tangents. All right, I do have to end the lesson here just because I've got a thing I got to get to here at 9. I'm going to go ahead and stop the recording here.